Hello and welcome back to another episode of the Building HVAC Science Podcast. The ultimate goal of this podcast is to help our listeners create better environments for all people. And a lot of that comes from planning, engineering type planning. This episode, Eric Kaiser sits down with mechanical engineer Tony Amadio, founder of True Loads. And they talk about what actually makes residential load calculations succeed or fail in the real world. Tony shares how his work is split between builders, architects, project managers, and HVAC contractors, and why the biggest early battle was simply getting people to trust results that pointed to smaller equipment. It seems to be a repeated theme in the places that I listen. He explains how he quickly learned from feedback loops in production housing, including what happens when people overvent tiny spaces like closets and bathrooms, accidentally stealing airflow from bedrooms where it matters. Tony walks us through his approach to receiving plans, emphasizing the importance of nailing down the building envelope inputs, windows, insulation, attic conditions, and getting key assumptions in writing. On renovations, he emphasizes that uncertainty is normal, so you lean on photos, field verification, and practical guidance to keep the model honest. They also dig into infiltration and leakage, where Tony argues the models are still imperfect, even with blower door data, and the real win is setting expectations, such as the HVAC design needs to work under specific building conditions, and if the building doesn't match these conditions, performance issues are not automatically sourced from bad calculations. So let's get into this episode. You can listen to Eric and Tony talk about Beyond Manual J, the heat balance future of residential load calculations.
Hey folks, welcome back to the Building HVAC Science Podcast. Eric here. Bill Spohn is not on this episode. He is somewhere in the ether, but we won't get into that. But I do have a special guest with me today, Mr. Tony Amadio. Tony runs a company called True Loads, and I'm going to let Tony tell you a little bit about himself. So Tony, welcome to the show.
Hi. Good morning, Eric. Thank you so much. Or good afternoon on whichever time zone you're on. Yeah, thank you. I'm a licensed mechanical engineer. I've been doing HVAC, load calcs, energy calcs, mechanical plans, duct designs for about 10 years. And I've also have my True Load software that's going to be out soon, a few months away, doing very accurate heat balance method, residential load calculations, and then going on to mechanical plans with that too. So I got two things in the works, transitioning from one and the other. But yeah. So it's been very busy, very fun. And I'm always learning, and I'm always learning from you guys and your podcast too, from some of your field folks and expertise and science and instrumentation. So thank you.
Awesome. Well, we're happy to have you here. So let's dig in. You're doing a lot of residential. You said you do some commercial work as well, as we were talking here a little bit before the show. And as an engineer, my background is primarily field experience, working with customers and things in the field. Who do you work with most of the time? Do you work with the end users, or do you end up working with contractors or designers more often than not?
It's almost a mix of 50-50 between call the 50% builders or architects or project managers, and then the other 50% about HVAC contractors, maybe sometimes some homeowners. Much of my work has been word of mouth, but definitely with some HVAC companies that have. So, for example, one of my designs have probably been done hundreds of times on, say, a Pulte or a Lennar or Taylor Morrison home. So trust me, you get to see your results real fast and see how good or not so good you do.
That's an interesting comment you made right there. And I want to pull that string a little bit more. Seeing your results. How often do you get, as the designer, sometimes the designer doesn't get to go back and really see their results. How often do you get to do that?
Quite a bit, especially early on when it was slower. And back in 2016, 2017, people are just like, do I have to do this manual J? Nobody wanted to pay you the price for the manual J. It was kind of a surprise. And then, manual D2 or the duct design and then the energy compliance calcs. When I started, I didn't have a lot of feedback. So nobody believed the calcs. Nobody believed the engineer. Nobody believed the designer. So everyone was trying to up it, pushing back. There's no way this 2,000 square foot home will be cooled by 2 tons. And that's a typical common Florida home when you have ducts in a conditioned space or something. So it was a big battle in the beginning. But then, you were seeing airflow issues. So, for example, a lot of builders or HVAC contractors insisted you had to have a supply in every closet, every little toilet room, and they're just robbing your airflow. So I saw that this could be a problem. It only needs 2 CFM. I think we should keep it out. But no, people put it in, and then next thing you know, you've got cold bathrooms, cold walk-in closets, and hot bedrooms. So you're like, oh, I'll never do that again. And you fight like heck. But then finally, in time, people start to believe in the calcs. People without the calcs with equipment too big was getting condensation, sometimes mold. So it took a few years until people started actually believing in the results. But load calcs and duct designs are, believe it or not, two different things, and both need to go together, I think, to have something that's going to work out really good.
Yeah. And to add on to that, equipment selection is a whole nother different thing too, beyond design, doing the load calculation and then doing the duct design. So let's talk about your process. When you're going to go in, we'll say you get a set of plans, because I'm guessing you work on a lot of new construction from the sounds of it. You get a set of plans. What is your process once you get that set of plans? Walk us through that from start to finish.
Well, I know you mentioned new construction, but I'll put in renovation work as well too. I treat every home the same. What's the building construction? What's the insulation? Now, when I do a lot of work in Florida and maybe New York and some other states as well too, I'm pretty familiar with the IEC codes and then the Florida energy codes and the common constructions there. So I kind of know, looking off the plans, yep, here's everything. When it's a renovation job, you have a lot less information. So you have to ask. You have to say, can you give me this information? If it's something really critical, you maybe have to put it on hold until you get that information, such as window performances. Now, if you don't have that, and then the builder or the homeowner doesn't have that window information, very important, big impacts on residential load calcs, not as much on commercial, but much more on residential because it's dominated by the envelope load. You could guide them and say, well, hey, look, here's the energy code. The common windows in your area is double pane low E vinyl. I recommend you get this, and whichever manufacturer you want is fine. So you sometimes have to guide people and you make sure, hey, look, my calcs are only as good as the home you build. People try to overthink the load calc. What if this? What if that? What if this? Say no. The homeowner or the builder, or this is what the building has to be to meet energy code. This is the home I'm modeling. I'm not modeling 20 homes of the same floor plan, R19, R21, double pane, single pane, metal frame, vinyl frame, spray foam, vented attic. No, it's going to be this. And you've got that in writing. You put that in writing. You've got your compliance energy calcs as well too, and say, this is what I gave you. If anything changes, let me know. So you start with getting the building envelope. Sometimes you get homes without an address. Maybe it's going to be a master plan that's going to be done every which way too. That's another special case where you've got 16 to 32 compass point directions. But yeah, so it starts with making sure you have all the information. If you don't have it, you got to get it. Some people are embarrassed or nervous to ask questions. People tell me things all the time. I'm on the road, I'm on the phone, and I just say, can you just please email that to me? You want it in writing. And sometimes you just have to ask the question again. Just make sure you have it because you don't want to mess that up. I have on a few homes in 10 years messed up the insulation values and people are pointing fingers. So definitely you just got to get that right, get the envelope right, get that cleared away. If they don't know, if they're looking for guidance, just say, hey, look, let's model it this way.
Yeah, give them a direction. One of the big things I hear a lot about on load calculations out there now with people that I think are really digging in deep is leakage. How are you dealing with that in a house where it's being remodeled or it's being built brand new? Do you model that leakage with code compliance targets, or are you having that discussion with the homeowner or the builder like, hey, can we maybe go farther than this?
Yeah, that's always the fun one. And just even in software, there's a lot of infiltration models. And I'll be honest, none of them are perfect. None of them are good. And then you got to say, well, where is that infiltration coming in from? I don't care. Even if you have a blower door number, is all that infiltration coming in through the basement? Is all of it coming in through the kitchen? Where is it coming from? And that impacts your load. And then in the summertime, if you have a perfect airtight second floor addition, all that hot air is going to rise up is what's going to happen when you have a leaky home. So the truth is you can't. So basically you have to put the responsibility on the building. Remember this, and this is my general saying is this: anyone who is detailed and thorough and good at a load calc software, you, me, whoever is doing the load calc on this one particular building, we should have the same result. Pretty darn close. So with that being said, if the building isn't right, okay, or if something's not right with the HVAC system, I don't think it's your calc, it's the building, okay? Did they get the right windows? Was it air sealed? And especially on renovation homes where, hey, we're not going to touch the basement. It's a 150-year-old home, but everything is new on the second floor. I advise people, hey, look, you really got to do the best you can to get a blower door validation test. You got to spray foam those rim joists, do something to make this as tight as possible. I'm not on the boat of you need to make a submarine. Trust me when I say at some point, whether you're 3 air changes or 2 air changes per hour, you look at that on the load and that's not that big. It's not going to change your calcs by a half a ton unless it's a really big home. But when you have a really big home and you've got a couple of systems, a half a ton difference is quarter ton, quarter ton. I'm for a very tight home, but it doesn't have to be a submarine, but definitely a leaky home could be a big, big issue. That's more of an issue with renovation homes. It was an issue with new homes built in 2015, 2016, when they weren't doing the blower door tests. And you were assuming, hey, look, the energy code says blower doors, but the state isn't enforcing it, and people weren't doing it. Same thing with duct leakage tests. But we've come a long way now in new construction. The risk is really small, but definitely in renovation, and as many people, they're all on budgets. You just have to insist. I can't control what the project manager or the building or what the homeowner does, but I could say, this is going to work under these conditions. If you don't have these conditions, there's no guarantees it's going to work.
Gotcha. You share that responsibility there with them by saying, hey, look, I'm going to do the calculation, but you got to make sure that the home works to match that calculation. Or if you can't get there, we got to have another discussion then.
I always, when I get calls from HVAC guys, I said, since when is this your responsibility? If you're getting the house 75 degrees on the hottest days in summer and you've got 68 relative humidity, sounds like the AC is working, but sounds like there's a building issue. Why is that your responsibility? If you follow these mechanical plans and everything's working right, the T&B, you're verifying it, you're not bringing in too much outside air, sounds like it's a building issue, and you need to tell the homeowner or the builder, you maybe need to get a building science or an energy rater expert in here to check the tightness of the home and check for things. At the same time, too, I always advise HVAC installers or some of the contractors, hey, look, if you see a problem, it's probably a problem. Let them know you're doing a vented attic and you don't see any vents. You're working in pure darkness in a attic. You don't see vents. That could be a problem. Trust me, it will be. So just note some things. Or if you're dealing with a renovation home and there's 3 inches of insulation, I probably didn't model R6 vented attic. I probably modeled R30 or R40 or something like that. Tell the homeowner, say, hey, you need to get your insulation up to code, and then this is going to work out just fine.
But let's switch over to some of the things you've seen over the years doing load calculations. What are some of the challenges you see with some of the software we have, some of the, we'll say, information gathering methods we have out there in the field? Because if you're going into an existing house, obviously you're going to have to gather a lot of information on that existing house. It's probably not on a plan somewhere on a lot of houses. What are some of the challenges you see with that?
With a lot of renovation work, it is some ping pong. It's back and forth. It's asking, hey, I'm doing a 100-year-old home or even a 50-year-old home in Maine. Is it 2x6 or 2x4? Is it insulated? I was wrong a couple times where I thought, hey, a 1960s home should have something in those walls. And it turned out it didn't. So that was a mistake for sure. And that was some time back. Yeah. And if people don't know, we have to say, hey, look, could you take off an electrical outlet? Could you drill a doorknob hole size and do a drywall repair? How about an IR camera? It's the wintertime. Are the studs warmer than the center wall, or is the center wall warmer than the studs? That tells me already, can I assume R9, R11, or something like that if it was 2x4? So photos, a lot of times you don't have existing information on the windows. And if they're single pane, you just got to maybe take the more conservative window for that. If it's double pane, but 10 or 15 years old, you assume the seals are there and you've got that U factor of 0.6, 0.5 or something. So you could use tables, but a lot of times we use tables. It's not bad when you don't have anything else. So unfortunately, with a lot of the softwares, yeah, we depend on tables. We depend on their infiltration model, how they apply that infiltration load to each space. Definitely, I've always complained about the blower door method infiltration, and I would love for your listeners to test this out for me and say, hey, look, model a home as average leakage. Then model a home as 5 air changes per hour, 3 air changes per hour. Tell me the infiltration difference. You'll probably find the infiltration with a 3 air change per hour, which is today's standard for air tightness, probably has more infiltration than a average home using the simplified infiltration method. I don't trust that formula. Everyone is all into the blower door for the modeling of infiltration. I'm just saying it's a formula that needs to be corrected. So when you play with these things as a software developer, and I'm going to put in the latest and greatest material properties, construction methods, wall conduction, roof conduction, floor conduction, and yes, the infiltration, which is really the big black box mystery. If you have a townhome, a 4-unit townhome, you've got the interior unit and you've got the end unit. Well, the end unit has more than twice the exposure as the interior unit. Do you model them both as 3-year changes per hour? Or do you model it in terms of floor area leakage or exposure leakage? And all this stuff gives you different results. But definitely when the home is leaky for sure, that's when you do run into trouble. That's when you do have condensation, even on insulated ductwork in a conditioned space. A lot of ductwork in conditioned space is uninsulated. I think a lot of uninsulated ducts are great products when you're in an airtight cavity. But when it's a leaky, warm, humid air, that 55, 60 degree supply air temperature can condense, and then you can get water inside the structure.
Yeah, so it's clear that you're in Florida right now, to me anyhow, as I'm listening to you talk, because you talk a lot about humidity control and ducts and condensation and things like that. So I'm going to say you do a lot of work in very humid and warm environments. Am I right on that?
True, but you do have those humid areas even in New York at certain times of the year, even in the New England areas, even in the Southeast. I tell people I lived in Memphis. I think the humidity is worse there. Great barbecue, but those could blow your loads too. Many of these multifamily homes and apartments and whatnot, they're not getting dehumidifiers. So you got to do the smallest size system possible to get the job done. And that's how you're going to maximize on your moisture removal. But a good thing is, and I just like to point this out, this is in the energy code, that we're actually not responsible for indoor humidity. Don't get me wrong. I love 50 relative humidity. I notice a difference between 50 and 60. My typical preference is when I'm below 55 relative humidity, I feel good. Okay. When I'm above 55, 74 doesn't feel good. Okay. I probably need to be colder. So it's that ASHRAE thermal comfort chart. But hey, in Florida and Memphis, single stage equipment, I'm responsible for 75 degrees on the hottest summer days. I'm not responsible for humidity. Definitely there's things people could do to improve that. But if you're doing a production built home that are not buying these dehumidifiers, hey, if you get 55 relative humidity, 58, it is what it is. As long as I'm cooling the building, as long as I don't have condensation, as long as that means I'm not going to get mold. So I'm not saying that that's perfect, that's great. No, it's not. But that's always something extra if you want temperature and humidity control. If you want that humidity control, that's an extra.
Gotcha. So you're saying that if we do a basic load calculation and just a typical heating and cooling system in a residence, that we're really not responsible for the humidity because we have no controls and no equipment to directly control that humidity.
Yeah, exactly. And if I'm answering your question correctly, basically the way to put it is most homes, single stage ACs or single stage heat pumps. You can't control humidity. Look in the residential code, look in the residential energy code. There's nothing that says 50 relative humidity, nothing at all. Okay. So you're not responsible for that. And that's very important for people to know. So dehumidifiers are an accessory. I think they're great. I think they're wonderful. I'm a fan. But if people don't want to pay for it, don't call me if you're 56, 60 relative humidity if I'm getting you 75 degrees. Now, there's a difference. Let's talk about equipment selection. Here's something that's really important. Why I'm a fan of the old Manual S and not the new Manual S, although I can't wait to see the third, but I'm familiar with the normative, is we used to size HVAC systems on total capacity prior to the second edition Manual S. And you can look this up in the tables. And then 2016 and probably in the 2017 and 2018 codes, second edition Manual S was written out. We looked at latent, we looked at sensible. My issue with sizing on latent is if it bumps up the sensible too great just to satisfy the latent, you're going to short cycle more. So if I'm not running 10 minutes, I'm not getting any moisture out. So there's a difference between latent capacity and latent removal. Having more capacity is great, but if you don't run it long, you're not going to get the moisture out. So I tend to err on the side of total. I won't 15, 20% oversize on my total to satisfy a latent load because I know I'm going to run it much less. So capacity is misleading. I'm okay with 55 relative humidity if that's what I get. And by the way, a reminder to people doing J calculations is you don't have to be 50 relative humidity in your load calc. You could be 40. Go to Idaho, go to some parts of California. You could be 40 and still be a negative latent load. You could be a very big latent load in Memphis, okay, but you could change that relative humidity to 55 and make your manual less work. It even says so in the manual J. Even in some of the ASHRAE handbooks, you could even go up to 60. And then, boom, hey, look. But still, even with that, that's a calculation. That's a particular point in time. If I get you 75 degrees or less in the hottest summer days, mission accomplished. If you want the dehumidifier, I recommend you get one. This is going to make you much more comfortable, make you much more drier. If they don't, and if I get 58 relative humidity, even if I get 60, if I don't have condensation, I'm not going to get mold.
Okay. I like that thought process right there, that if we don't have a control and or equipment that is designed to control that humidity, that we really can't be responsible for it.
Right.
And somebody's got to pay for that. Somebody's got to design it. Somebody's got to look at this and say, hey, you're either going to get what you get, or you're going to put in equipment and a controlling system, some kind of a control system to actively control that humidity. Otherwise, we're really passively controlling it. We're just getting lucky. We can select equipment. Now, you mentioned the third edition of Manual S in there. That's been out for what, 2 years now? A year?
I know there's more recent versions. I think last I checked was a month ago that the third edition Manual S, I think the normative is out, and it's probably been out for a few months, but they haven't published the full edition yet. I believe in the newer codes may be coming in the 2027 IECCs and probably the 2026 Florida. I'm in Florida, by the way. So some of the codes being published or this coming year for the next code cycle will reference the third edition Manual S. But I believe the entire volume is not out yet. Again, if it's not in the code, we're still on per. It's one thing to use the latest and greatest manual, but it's another thing to meet code. Let me tell you something about code, and this is just my take, is code is your lifesaver. I'm not here to bash code, and people put the perspective of code is the bare minimum. I don't look at it that way or put that spin that whenever you do something beyond code, you're doing something better. That's not always true. You could have a very tight house and say, I don't want 50 CFM bath exhaust fans. I want 80 CFM exhaust fans. And the next thing you know, you depressurize that home so much, you're going to have issues drying your clothes if you don't have a ventless dryer. You've got 3 people in the bathroom with 80 or 110 CFM exhaust fans in a small, tight home. You're not going to get that exhaust flow, by the way. So when you stick with the code in terms of, hey, look, if I set meeting the code says 2nd edition Manual S, 8th edition Manual J, see what the code says. There's a duct sizing chart for kitchen exhaust. I know a lot of people like to use that 6-inch pipe for 500, 400 CFM range tops, but look in the code, it tells you to use an 8-inch duct, okay? And of course, anything bigger, maybe you need to do a little basic duct sizing calculation for that. But going back to the code, yeah, there's nothing on humidity control in the code. And HVAC systems are HVAC systems. We didn't say dehumidification. Even a variable capacity system, oh, I could oversize that by up to 30%. Well, that's great. Well, if I could have a 3 or a 4, and I'm spot on my load calc on a 3, even a little undersized. Remember, Manual S says you can undersize by 10%. It's just a number. Load calcs are very conservative. Typically, they're conservative by about 20%. But don't do that 4-ton variable capacity because you'll have much less humidity control. But even with the perfect size 2-ton or 3-ton variable capacity, and it could control humidity within a certain range, it's not a dehumidifier. Okay.
Would you use the latest edition then if the codes were just to say, use that latest edition of Manual S rather than calling out a specific version of it?
You always want to be up to date. You want to know what the latest and greatest edition is, whether it's a calcs and Manual S. But remember this, and I don't know if some of the folks remember this in 2017, 2016, when we started going above 15% oversized on equipment, it was rejections on your calcs. It was rejections in the permitting process. A lot of that was happening. And then you had to go give this whole explanation. Thank goodness Manual S 2nd edition had that one-page table that showed single stage, multi-stage, or variable capacity for 15, 20, 30% oversized. I hope the 3rd edition Manual S has something of a very easy language for plans examiners to look at, digest, and say, okay, we went from 20% oversized equipment on 2 stages to 25% or 20% oversized on some 2-ton single stage systems or something like that, okay? That could be hard to pass. So just because it comes out and says you could do this in the Manual S 3rd edition doesn't mean you'll get it approved if the plans examiners don't buy it, okay? So, hey, that's fine. If you want a 20-something% oversized single stage and the plans examiner rejects you for it, you make someone get a variable capacity and say, hey, look, this is the only way I could get this approved.
Gotcha. I did want to throw out there, Manual S has been out, the 3rd edition's been out, and ACA changed the way that they're doing that particular manual now. They're actually providing the normative section at no charge to everybody. So that one is now you can go on their website and just view it through Manual S. You can download it, but it has to be online and viewable to be able to view that. And then they are publishing the informative section. That will be a for purchase book, but they're now separating those two sections of that manual so that they were able to publish the normative section pretty early on, which for our listeners out there, that's the one that has all the actual requirements, the code language in it and everything.
Yes.
And then the informative section teaches you how to use that. So my understanding is they're going to be publishing, and I think it was supposed to be out a while back. I actually talked to Wes over at ACA a little while ago about that, and he said they're still working on the informative section, but it's actually going to be a nice book and try to help the contractors utilize that a little bit more. So I think that was a good move on their part.
Yeah, it gets better and better. And don't get me wrong, I love it. I'm always loving the new information. On the normative, just to give you 2 changes that I notice is now they have guidance for dehumidifier sizing, much better guidance than before. They did increase 2-stage sizing from 20% to 25%. You can now 25% oversized for 2-stage systems. So just keep that in mind. The reason I mention that is if you 25% is 2-stage system now under the current codes, that 3rd edition Manual S isn't in there. It's the 2nd edition, and plans examiners are only going to follow what's in the code. The reason they came out with that normative section very early was to get into the codes being worked on the next code cycle in many of the state enforcements.
Gotcha. Some really good information there on how to select that equipment. I like some of your thoughts in there. That's really good. Where do you go to find a lot of your information on equipment selection? Are you doing the equipment selection, or are you leaving that up more to the contractors?
I do the equipment selection. As a designer, a lot of times I don't know who's going to do the install. It's great when half my clients are HVAC companies. This gentleman's a Carrier, that gentleman's a Lennox, or that lady maybe Daikin Goodman or something like that. That's all really great. Most of the time I don't have that information. So, okay, what has public information out there, full capacity specs, your full performance capacity for different temperatures and airflows? Goodmans have that, which is great. So generally I'm picking a Goodman, but definitely, by the way, with regards to code, or once you get that paperwork approved, tonnage is a big thing in terms of, hey, am I meeting code here at the installation? You can't put in something bigger once things have been designed and permitted on 2 tons or 2.5. You can't come in and put in a 3 or 3.5, but someone could come in and put in another manufacturer. So remember, this is code doesn't say I have to do Owens Corning R19 bats. I can't use Rockwool. I can't use John Mansville. Code doesn't dictate the manufacturer. So really, I'm in a black box again. But look at the sizing: 2 tons, 2.5, 3. This is why I don't weigh too heavy on expanded performance data. I love AHRI information. This is the unpopular opinion that I have, but I'm a very big fan of it, is to say, hey, look, AHR is the only third-party verification on capacity. Okay, otherwise I got to get it from the manufacturer. And if I don't have that account information, if the contractor doesn't have that information, how could I do a complete, super accurate Manual S? But then the question is, do I care? And I don't mean that in a bad way. What I mean is, if my AHRI says I'm 22,000 BTUs on a 2-ton, and one manufacturer may be 24, one manufacturer may be 23, and I don't know the latent or sensible splits, and I can't get that information in time. But if my total heat gain on that load calc is 23, 22, 21, I'm doing a 2-ton. There's just no way around it. I'm doing a 2-ton. I'm not going to do a 1.5 tons. I'm not going to do a 2.5. And again, if I could satisfy 75 degrees on the hottest day, mission accomplished. If the humidity is above 50, that's okay. Are you comfortable? Number one is, are you comfortable? If you're comfortable at 55, if you're comfortable at 60 relative humidity, no condensation, we're good. We're good. I had a friend who, if you went below 50 relative humidity, she would get bloody noses. She was maybe from some other area where it was really, really humid, but just some people can't be that dry. But I am not too concerned by using AHRI capacity for sizing equipment. Now, what about in California? Okay, you may have 105-degree days, or Arizona 110, 115. Well, remember, this is the peak time of day is going to be somewhere between 2 and 4 o'clock, okay? But the peak heat gain entering the building is going to be 8 o'clock. Believe it or not, I know everyone thinks 7, but usually it's 8 o'clock or later because the walls are having more insulation in the newer construction homes. So California, Arizona at 8 or 9 p.m. or even 7 p.m., that outdoor temperature isn't at that extreme point in time anymore. So even though we look at things at one point in time and you look at that weather condition at one point in time, most often than not, by 8 o'clock, you're below 90 degrees. So from a total capacity, I'm not concerned about the AHRI being rated at 95 degrees.
Interesting. Let's go back on that, what you just said there, because I want to break that down a little bit. What you're talking about is essentially the delay time that it takes that heat to transfer through that wall, because just because it's 110 degrees outside doesn't mean that that heat is immediately transferring through that wall. You've got a delay in transfer because of the insulation in there. Am I understanding that right?
You're absolutely right. Yep. Insulation, the mass, the heat capacity, the thermal conductivity of the entire assembly. Yep.
Okay. Well, you mentioned earlier that you're making and putting out a software in the near future. Tell us a little bit about that and tell us why you decided to do that. And you mentioned that you're using some different calculations in that maybe than have historically been used. So let's talk about that a little bit.
Thank you. So I'm using for True Loads for residential software that I have. It's not doing the manual J method. In fact, I even believe the manual J method coming up in probably the 9th edition is going to be very different from what we're used to today. So it's going to be a different story. I think I'm probably ahead of the game. So this ASHRAE heat balance is the latest and greatest method, although it's been out for well over 20 years. But the manual J, the CLTD, the reason that was created in the 70s, or equivalent temperature difference, now cooling load temperature difference, that was a way to simplify load calcs for people to do things by hand. And then eventually, once computers were becoming popular and cheap, now you have some good cooling load programs that do the manual J method, but it's still doing a hand calc method. All that stuff's actually based on the 1980s. So having a thick ICF or a thick SIP panel home, having a double stud home, okay, the manual J is going to be very, very conservative, at least by 20%, overestimating just on the envelope. Okay, not talking infiltration, although that's quite a bit off, I'm pretty sure on that. So the reason I wanted to do something different was I didn't want to be another manual J software. Here's another manual J tool. I wanted something really accurate, something that could capture today's construction methodologies. And then the other thing was, most often people don't know this, that you can't really do manual J on high-rise buildings or many of the multifamilies if it's got 1 or 2 exposures. Manual J, the CLTD, is a time averaged, orientation averaged CLTD, and it's for a specific construction. However, we take that specific construction and we use it for many, call it a window of constructions as an approximation. But being able to do something hourly, I could say, hey, look, I've got this hotel or I've got this condo in Miami and I face the ocean, or I got the condo in Tampa and I'm facing the West Coast. The time on when that peak comes and the solar radiation intensity of what that is, what is the real peak load? You could only do it with an hourly. You could only do it with something that hasn't been time averaged in CLTD orientation average. So you got to get to the core physics. And we have the capabilities of doing that. A lot of the commercial softwares today, they went away from CLTD probably 15 years ago. Some of the good commercial programs are doing the RTS, which is still a simplified version of the ASHRAE heat balance, but it's not the ASHRAE heat balance. So doing the heat balance, it's the core material property physics, the actual time delay and thermal lag, thermal mass, all that stuff, because I've got the core property information. And based on the location, I've got different radiation intensities and different profiles throughout the hour. CLTD has some adjustments for latitude and location, but it's very weak. The thing is with an ASHRAE heat balance is it doesn't matter what construction, it doesn't matter what location, what part of the world, or if it's got one exposure, two exposures, or high rise, it's going to model that envelope load pretty darn accurately.
Interesting stuff. This is going to look a lot more, I guess, like some of the energy modeling software perhaps, or is that going to be still different from that?
Great question. You're right. The energy modeling is doing the heat balance method. But my goal with True Loads is, and I've been keeping true to this in the development, is it's not going to need any more inputs than what you currently do to do a J. In fact, it's going to have less inputs. There's a lot of redundant inputs in manual J where, hey, look, if I could have ducts in an attic, okay, in a vented attic, but then I have an encapsulated attic, and you got to fix all that stuff in many of these other software programs. Everything is piece. You got to specify. So maybe having less questions and getting to the right formula set up in the software. Again, just less redundancy. I shouldn't have to say I'm 3 stories or 2 stories or here's my exposure. If you draw a 3-story building, you better know it's a 3-story infiltration model. So a lot of that stuff, it's not going to ask you. You can build every wall. Unfortunately, when you're getting to complex building constructions like double studs and then any sort of other funky constructions, you got to ask the question. You got to know what that construction is. But other than that, it's going to ask less on the internal loads. My software is going to have internal loads built in. You shouldn't have to put in 2 people in the master bedroom or in the living room or the TV or the kitchen appliances. I mean, once you know it's a kitchen, it's a kitchen. It's got standard appliances, but you could put in more if there is more. If you know someone's got 2 refrigerators and 2 freezers in their kitchen or 2 water heaters in their utility room, you have that control of doing that. But there's going to be some default internal loads, so it's not even going to ask you what the internal loads are. It's just going to be built in based on the space type. So it's going to save you time.
Interesting. So is that going to be like an online tool, or will it be through an app, or how will that work?
We're still doing some stuff on maybe making it maybe a desktop version as well, but we went with the direction of doing it as a cloud-based software. The reason for that is I hate spending a few grand on a laptop every 3 years because of the graphics and the consumption for many of the tools that I use. If it's something on the cloud, of course, you need good internet, but if it's on the cloud, it's not going to have a graphics issue or a delay or a lag that a lot of desktops do. Updates will be automatic in the software. The user doesn't have to do anything. You could go use your computer at home. You could go use your computer at work. You don't always have to take your laptop with you. So having a cloud-based software was a direction I decided to go with True Loads. But maybe having something later on as a download, and then even going into the future, having something of a phone app as well too for other things in the probably a year away. But I'm very close to having at least the heat loss, heat gain, a manual-less compliance report in our True Loads. So yeah.
Very nice. We're getting close to wrapping this one up here. A lot of good information, Tony. Thank you for coming on here. I do want to ask you, any final thoughts you want to share with the listeners out there?
Well, on load calcs, if I stick with that, is I look at load calcs as something that's fun to do. Not fun, but I could have a drink and do load calcs and relax a little bit, okay? Pay attention, be thorough, be detailed, know what your responsibility is. And then, of course, when it's duct designs and you get into that, that's something even further. But trust your loads. If you're paying attention to detail, you're paying attention to the overhangs and all that stuff, pay attention to the details. Your load calcs aren't wrong. Don't worry about it, okay? Even in commercial, I tell people commercial load calcs are actually easier than residential loads. Residential loads is very envelope dominant. In commercial loads, there could be a lot of unknowns, but there's a lot of other stuff going on in there. So if you could do residential loads, you could do commercial loads. If something is wrong, if something's not working, it's probably not your load calc. It's probably something else, okay? So just to give you a little bit of confidence in there, my website is 1dtrueloads.com. We'll be having updates and free trials pretty soon. I'll be at the AHR Expo in Vegas. And so feel free to reach out, check me out, and yeah.
Tony, thank you very much for coming on today. We really enjoyed the conversation here and all of the knowledge shared today. Folks, we will catch you on the next one. Thanks a lot, Tony.
Thank you, Eric. Thank you.
Thanks for tuning into this episode of the Building HVAC Science Podcast. One of the notable quotes from the episode I should have mentioned before is, "Make it as simple as possible, but not simpler." you have any questions or want to suggest a topic, reach out to us at marketing@truetechtools.com, TRUTECHTOOLS.com. Some of the topics we discuss require technical training for proper interpretation or safe execution. So if you're a trained pro, you can proceed immediately. If you're not, please consult with and hire a trained pro. The Building HVAC Science Podcast is a production of TrueTech Tools Limited. In full disclosure, I'm a co-owner of TrueTech. The opinions expressed are those of my guests, my co-host, or myself, depending on who is speaking, of course. And if you're in the market for any tools or test instruments mentioned in our podcast, look at what TrueTech Tools has to offer. That's TRUTECHTOOLS.com. You can use the offer code HVACBS for a nice discount. I want to thank you for listening to us and following us on Building HVAC Science. Please spread the word. We hear a lot of good feedback from people that listen, and hopefully we'll hear that from you too. Thanks again. Have a wonderful day.